Welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet. And why? This week, we're chatting about repeated disruptions for both Anthropic's Claude and the social network X. We'll also be bringing you up to speed with the latest global outage figures. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Claude has experienced a few disruptions in April, but when you look across these incidents, it's not a simple "the service went down" story, is it?
No, and I think that's actually the most interesting thing about this one, because the easy headline is Claude keeps going down. And if we're just watching the outage trackers, we'd probably walk away with that impression. But when you look at what actually failed across these three incidents, they're not the same story at all. In April alone, there were the three separate events that Anthropic acknowledged on their status page. So this was on April the 8th, April the 10th, and April the 13th. And each one was hitting a completely different part of the stack. So April the 8th was specific to Claude's Sonnet 4.6, which is one of Anthropic's main production models. And the failure was contained entirely to that model's back end. So nothing else was affected. On April the 10th, that was an inference layer issue. Inference being part of the system that actually runs the AI and generates responses. But it only affected certain models. And we're going to come back to that because that's really telling. And then April the 13th, which got the most public attention, was actually an authentication and login failure. So users couldn't actually get in. But the models themselves, if you could get in, were actually fine. So 3 incidents in roughly 2 weeks with 3 completely different failure domains.
Let's take April 13th, since that got the most public attention. What did it look like from a monitoring perspective?
Yeah, this is actually a good example of what a relatively contained but highly visible incident could look like from our data. Reports the outage climbed sharply from around 11:45 a.m. Eastern Daylight Time and then sort of fell backwards toward what would be normal levels within about an hour. So in terms of duration, this was a fast-moving event. What's interesting is that Anthropic classified it as a major outage on their status page, which might seem like strong language for something that sort of resolved reasonably quickly. But that classification is about the scope of who's affected and not how long it actually lasted. So when you can't log into Claude at all, that's a significant impact, even if the engineers sort of fix it within 30 minutes. So the failure itself was in the authentication login layer. What we were seeing in our data was elevated error rates against Claude.ai, with HTTP 500 responses indicating something had actually failed in that back end, that server side, rather than the service just being slow or under load. From a synthetic monitoring standpoint, when you're running these automated tests that emulate what a real user would do, this type of failure surfaces well because we're testing that login path and the errors are unambiguous. So the window from the first signs to trouble to resolution was somewhere in the region of 45 to sort of 50 minutes. One thing the data did show is that the status page acknowledgement came sometime after the impact was already started to be seen. And that's actually not unusual. Typically, internal monitoring tends to be built around instrumented infrastructure. So an issue typically has to accumulate and surface through logs and events before it sort of registers. If you're doing sort of this proactive testing or from a user perspective, it doesn't have that same lag because we're continuously testing that user experience. So it sees a failure at the same time as the real user would. So you actually sort of get that head start rather than looking at a lagging indicator.
The April 10th incident is probably the most technically interesting one. Only services not using Claude's most powerful Opus model were affected. Opus was fine. What does that tell you about how the back end is structured?
The thing that makes April 10th distinctive is the scope of what failed, and more specifically, what didn't fail. So if we're looking at this from a network level problem or a failure in some shared piece of infrastructure that everything sort of depends on, we'd expect to see everything go down together or everything or multiple services or systems impact itself. And that's not what actually happened here. So Opus stayed up and healthy throughout, while other models were hitting inference errors, with inference being, as we said earlier, the part of the system that actually runs the model and generates those responses. Now, the most logical explanation for that pattern is that Anthropic runs separate serving paths for different models, so distinct compute pools or backend infrastructure for different model tiers, rather than sort of one shared pool that everything runs on. And that's a reasonable way to build it. If your most demanding and likely most profitable model tier has dedicated infrastructure, you're protecting it from being impacted by load or failures elsewhere in that sort of real estate there. Now, the trade-off to that is that a failure in the lower tier serving path takes out those models while Opus keeps running, which is exactly what appears to have happened here. The odd caveat that is that I'm looking at this from the outside. So I'm inferring the architecture from the failure pattern rather than having sort of direct inside visibility of how it's actually built. If you're actually running sort of these types of service or service in production, a test pointed to one model only tells you about that one model. So if you're actually looking and checking Opus availability and the Sonnet equivalent is actually down, the monitoring is going to show green. And your stakeholders or users rely on that model are going to have sort of a very different experience. It's a good reminder that coverage needs to reflect how a service is actually consumed, not just whether the headline or the endpoints or the main front door is actually responding.
There's a hypothesis that some of this is connected to deployment activity, the Sonnet 4.6 model update specifically. Is that defensible, or is it reading too much into the timing?
So I want to be really sort of clear and upfront about this. This is just a hypothesis. Anthropic hasn't published detailed postmortems on this instance. So all I'm working from is sort of timing correlations and, if you like, inference rather than a confirmed root cause. But I do think it's actually defensible, and sort of here's why. So April the 8th was specific to Sonnet 4.6. We know from public announcement that this model was actively being released and rolled out around that time. That doesn't mean a deployment caused a failure, but in my experience, when you see issues that are cleanly scoped to one model or one backend, and that model happens to be going through an active rollout, that's typically where I'd actually start looking, or we start looking. Now, deployment-related issues don't always show up that neatly. But when they do, when it's that specific, it's usually pointing to somewhere in the change activity rather than an underlying infrastructure. Now, April the 10th follows a similar logic. So with other models failing at the inference layer, while Opus stayed healthy, it's at least consistent with a change being applied across certain serving paths, but not yet to Opus. Again, consistent with the hypothesis, but not proof of it. But to be fair to Anthropic, and I'm sure they weren't pushing sort of blind to production, the reality for anyone operating this scale is that however rigorous your pre-production testing is, you simply can't anticipate every interaction and combination until it's sort of running under load with real users. So it's not a failure of process, it's just the nature of a complex distributed system. And what makes it hard in this environment is that there are so many moving parts simultaneously. You've got model updates, infrastructure changes, then on top of that, load patterns that shift as different regions come online through the day. And I'll be honest, as someone who actually uses these services regularly, the degradation I personally notice sort of tends to cluster toward the end of my working day, which coincides with European business hours ramping up and US traffic starting to build. Now, I should be really careful here because that's just a personal observation and not something I've actually sort of validated completely across all the data there. But I think it's illustrative of the point that the load itself is a variable layered on top of everything else, which is actually where I'd land on this more broadly. And I think it's a useful key takeaway for anyone running these services in a production context. The deployment velocity question is real, but the more actionable framing is how well do you understand the moving parts? Because if you understand the architecture, the separate serving paths, the model-specific backends, the authentication layer sitting in front of it all, then when something does go wrong, you can not only identify that fault domain quickly, but you also know what action you need to take to it.
What does this April cluster tell us about the reliability challenge for AI services? Because it does feel different from a traditional cloud outage.
It does feel different. I think it genuinely is, not just in degree, but in kind. A traditional model for building reliable services is built around redundancy, geographic distribution. So if one region has a problem, you route traffic somewhere else, you need more capacity, you spin up more instances. And that works really well for stateless web services because the compute is relatively generic and elastic. So you can add more of it quickly and it's largely interchangeable. Now, AI inference doesn't actually work that way. So the compute is expensive, it's specialized, and it's capacity constrained. You can't spin up additional inference capacity on the same time scale you spin up web servers. The hardware's different, the lead times are different, and the economics are different. So this creates this resilience gap that's sort of harder to close than it is for a traditional web service. And I think that's sort of an underappreciated aspect of sort of how these services are built. Now, what April illustrates on top of that is that the failure mode themselves are more varied and more layered. So in the space of 2 weeks, we saw an authentication layer fail, an inference backend fail across specific model tiers, and a model-specific serving path fail. So 3 complete different parts of the stack each showing up differently and requiring a different diagnostic lens. So that's more complex failure service than you typically see with the traditional SaaS platform, and reflects the fact that these services have more distinct functional layers than might appear to from the outside. The other thing that sort of makes this environment genuinely different, and I think this is also underappreciated, is that we're not talking about a variation on client server or distributed web architecture. The dynamic is fundamentally new. So the model itself is continuously evolving dependency, the serving paths shift with it, and the interaction between those layers sort of create these failure modes that are harder to anticipate because the environment is in constant motion in ways traditional architectures simply aren't. And that's not a criticism of how these services are built. It's just a description of the territory as it exists today. And I think that's a useful takeaway from April. It's not that Anthropic had a bad month. It's that this class of service comes with different and more dynamic failure service than most organizations are used to reasoning about. So understanding that, understand the layers, the dependencies, the way they interact is what puts you in a position to identify what's actually wrong when something does fail, rather than just knowing something has failed.
X has seen several disruptions over the past few weeks. We're seeing repeated incidents rather than one big event. What's the pattern?
So X is an interesting contrast to the Anthropic story, because what we're looking at here isn't one significant instance. It's a series of smaller ones in quick succession. And I argue the pattern is actually more telling than any individual event. So in roughly a 2-week window, we observed disruptions on April the 2nd, April the 7th, and April the 14th. Now, none of them were sort of catastrophic in isolation, and they were degradations rather than X going dark or offline or completely out. And none of them actually sort of generated the kind of widespread coverage we'd associate with a major platform outage. April 2nd was probably the most visible, with users globally reporting feed and app issues over an extended period. April 7th looks similar, a broader degradation with problems showing up across the US, Europe, and Asia. And April the 14th appears to have been more localized, with users in France and Germany reportedly experiencing issues in the early evening. So 3 events are different in character, different in geography, different in severity, but all within this sort of 2-week window. And that's where I think you have to step back and ask what that pattern is telling you. Because when disruptions cluster at this frequency, it's sort of worth asking whether there's a common thread. Is it in the infrastructure, in the operation environment, or somewhere else? And that's the question I think is worth digging into.
Cloudflare was blamed in outage reports concerning the April 2nd incident. What was actually going on there?
So this one's actually clearing up because Cloudflare attribution was pretty widespread and it wasn't accurate. Their infrastructure operational throughout, and it's actually 2 separate things in the data that point you away from Cloudflare pretty quickly, which is a useful illustration how you build a diagnosis from aggregated evidence rather than looking at a single signal. So the first is exactly that, aggregation. If Cloudflare were generally having an issue, we'd expect to see it show up across multiple services simultaneously because of sort of how widely they're used. But what we were seeing was isolated to just X. Now that's the important pattern to recognize, because widespread failures that share common dependencies tend to show up together. When the impact is constrained to one platform, your first hypothesis should be the platform's own infrastructure and not that of a shared third party. The second is what our data was actually showing. So DNS was resolving correctly, routing paths were intact, connections were appearing to establish. So the failure appeared then to be at the application layer in how X's own backend was actually serving that content, not in anything sitting in front of it. That's a completely different failure domain. But the Cloudflare attribution is a common pattern, and it's actually worth understanding why it happens, because it tells you something about how misdiagnosis occurs in practice. When users start reporting problems, they often name whatever technology they associate with the platform alongside it. And Cloudflare, being so ubiquitous, gets cited into outage reports remarkably quite often, including situations where it's completely uninvolved. It's more of a familiarity bias than anything else. And this is precisely why that attribution step matters, not just for finding the fault faster, but because a diagnosis directly determines the action you're going to take. If you've concluded it's a CDN issue, you're opening a conversation with a third party and looking at a cache and routing. If you've correctly identified an application layer in your own backend, you're looking at config changes, recent deployments, service restarts. So that first diagnostic call doesn't just save you time, it actually determines whether the response you're mounting is going to be the right one.
X doesn't publish much by way of post-incident detail. Does the pattern of these disruptions tell you anything about what's likely going on underneath?
It does. And I think the most telling thing is it isn't any individual incident. It's what the variation across all the 3 tells you when you actually look at them together. So if you're seeing the same thing fail repeatedly, that's going to point you to one place, one component, one dependency, one part of the stack that's going to need attention. But what we're seeing with X is the opposite of that. April 2nd appears to have been a content serving issue where users could connect but weren't getting their feeds. April 7th had that broader degradation across the app. And then April the 14th was localized. So different failure signatures, different affected population, different parts of the service each time. And sort of paradoxically, that's sort of harder to explain than a single recurring fault because it suggests failures aren't coming from one shared component that everything depends on, but they're emerging from different parts of that stack independently. In my experience, when you see that kind of pattern, which is that varied distributed failures rather than a single repeating one, it's not quite a simple story. And the thing is that the platforms this scale are sort of living systems. So they're constantly evolving, they're constantly under load, and interactions between the parts of the stack aren't always predictable, or even to the people that are building them. What the pattern does tell you is the diagnosis isn't about finding that single broken component. It's about understanding how those layers interact, because a failure that presents at the application layer may have contributing factors at the network layer. And something that looks like a network problem may actually be the application behaving in a way to stress in the network underneath it. So getting that interaction model right is what lets you ask the right questions when the next one happens.
Let's close by taking our usual look at the global trends that ThousandEyes observed across ISPs, cloud service provider networks, collaboration app networks, and edge networks over recent weeks.
At a global level, it's actually been a relatively quiet couple of weeks. So across the April the 6th to April the 19th window, the global outages were fluctuating in a pretty narrow band, 250 in the first week, back to 240 in the second. So essentially flat. Now that kind of stability suggests that the broader network environment was in a settled operational rhythm heading into late April.
But the US numbers are telling us a different story, aren't they, Mike?
Yeah, they are. And this is where it gets more interesting. So while the global picture was stable, the US was moving in a noticeably different direction. So outages climbed 27% in the first week, then added another 6% on top of that in the second. So a sustained climb rather than a spike and recovery. And the proportion tells the story as clearly as the raw numbers. The US accounted for around 56% of all global outages across that 2-week period, against a more typical figure of around 45%. So the global number suggested a settled network environment, but the US data is sort of telling a different story. And that divergence is a thing worth paying attention to as we move further into April.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this help ensure you're in the know when a new episode is published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreports@thousandeyes.com. Until next time, goodbye.